So welcome to our final webinar for 2025. It is on membranes, moisture and fire performance in timber construction. We welcome you. My name is Samantha Charles and I'll be your host for this afternoon. I would like to firstly just give some thanks to our sponsors. These sort of things don't just happen, and we really appreciate their support. Our main speaker for today is Daniela he's the technical consultant for Rothoblaas. He is in Italy. We have Roy Southey, who is in Sedgefield. We have Mark O'Connor, who is also from Rothoblaas in Cape Town. And we have Tafadzwa, and she's in Pretoria. Not quite sure where Scott is from, so we'll find out where he is dialing in from. And actually, I am in Bangkok, so it's a few hours ahead of everybody. But again, we welcome you, and I think I'm going to hand over to Roy Southey, who is the Executive Director of Sawmilling South Africa. So Roy, can I hand the mic over to you?
Thank you, Samantha. And welcome to everybody who's in the meeting today. It's my privilege to welcome you all here. This is our 14th Talking Timber webinar since we started a couple of years ago. And as Samantha said, it's the final in 2025. So we're really gathering steam, as it were. When we started this project, we used to attract maybe 20 or 30 participants, and we're now running to over 100. I see today we've already got 85 in the audience. So thank you to all of you. Welcome to you all. And it's wonderful to be here. Obviously, my name is Roy Southey, and I'm the Executive Director of Sawmilling South Africa. And as we well know, that all timber structures, all timber buildings essentially start at the sawmill, so we have certainly a vested interest, and we're very, very privileged and keen to be part of this whole initiative of promoting timber in the built environment in South Africa. We are very lucky today to have a number of experts in their fields. And obviously, as Samantha mentioned, the talk today goes around membranes, moisture and fire performance in timber construction. Very, very important, an aspect that was maybe overlooked in the past. And as timber construction has gained popularity and gained preference in the world, as well as South Africa, issues like moisture control and membranes, and of course, fire protection is of critical importance. So as Samantha mentioned, we have Daniel Cunego from Italy. We have Mark, we have Scott, who I think we're still trying to get on the line, but they'll be here and they will expense their knowledge and expertise. And we hope that you people in the audience will enjoy their talks and will take in what they say and use it in your lives, in your professional lives going forward. We mustn't forget about the stalwarts here, Sam, who is the facilitator of these webinars. Sterling work she does, and she's become very efficient at it. So much so that while she's away in Thailand at the moment, she's in Bangkok, she's still been able to dial in and organize us all into shape, as ladies certainly always do. And then we have one of our main sort of sponsors, as it were, of these webinars, Tafadzwa from the DTIC, who have been. She heads up the DTIC's department on timber sort of beneficiation, which includes sawmills and pole plants and pulp and paper and you name it. So it's wonderful to have Tafadzwa here. She's always with us and lends us great support, and it's good to have the support of the DTIC and the government, of course. So without any further to do, I think I've had enough to say, so we will hand over back to Samantha and enjoy the talk. Thank you.
I am going to hand over to Mark O'Connor from Rothoblaas, who's going to give us a brief sponsors presentation. Thanks, Mark.
Thanks very much, Samantha. Great to be here. Yes, so thank you very much Ferdinand, all the big work that you put in behind the scenes. Roy, thanks a lot. Also special thanks to Bram de Villiers from Earthworld Architects. I'm not sure if he's here today, but he certainly, I think he was very, very instrumental in putting this talk together, from what we discussed the last time I saw him in Pretoria. Just a little bit about Rothoblaas, the company that I represent and Danielle represents. We're a company from the northern part of Italy. I'm based in South Africa. We've got a sales force in South Africa as well. We've got 2 guys in Cape Town, 1 in Johannesburg and 1 in East Africa. We're hoping to increase the sales force over the next few years as well. The next slide, this is a picture of our company headquarters. We have about 700 co-workers that work with us. A large part of that is on the sales force. We do about 150 million euros worth of turnover each year, in and around 30 subsidiaries, of which one of them is in South Africa. Here we go. Next one. Yeah, so that's our sort of mantra, close to you, wherever you are. One of our real strengths Rothoblaas has, not only is in know-how of how to build timber buildings, is we have the ability to supply significant technical products to big projects all around the world. So we're gearing up for these big timber projects to come online in the southern hemisphere, or southern Africa at least. But yeah, while we're here, we are developing the market, seeing what we can do, and sharing some of our knowledge on timber construction. So essentially, the business, Rothoblaas, is a business been around since the early 1990s. Started off quite humbly. It's not so humble anymore, but in terms of certainly the size and how it's grown. Really, where it started with tools, now it's really evolved to quite high-end fasteners, connections, hidden fixed connections, understanding engineering loads, performances in fire, knowledge on air tightness, acoustic performance, etc. Rothoblaas primarily works with 4 types of customers. We work with woodworkers. We work with building envelope, essentially structures, facades, roofs, etc. We work with retailers through our Hulse Technique brand, and we work with safety specialists. So this is a dedicated range of fall protection systems to allow people to work safely and in a certified way at heights. So our full range of products includes fastening, air tightness and waterproofing, soundproofing, fall protection, as well as tools and machines. Some of our resources include online My Project, which is design software. We've got a very, very comprehensive range of technical product catalogs, new products, a lot of video resources and training, including our Rotho School, which is actually where Bram attended, and I think this is where he got fired up about learning more about membranes and tapes. So this is a course that we did at the University of Pretoria last year, and it's certainly something that we're looking to repeat in South Africa over the, going forward over the next couple of years. I see one part of this slide is lost. This is an offer to anybody that is interested. This Ubicus software is free software, and it's designed to, you can include your wall makeups and roof makeups in this Ubicus software, where you can model basically any building material, including the inside temperature, humidity, outside temperature and humidity, and it will actually give you a full breakdown of where you are, what your R value looks like, and if you've managed to control your condensation points. So if anyone would like some assistance on this software, please, this is my open invitation. Please reach out to me and we can go through it together. And then from a commercial side, Rothoblaas also offers personalized membranes. So here's an example from one of my counterparts in Canada, where a modular construction company did a co-branding exercise on their membranes. So nice visibility on site. So please, if it's something that could be of interest to you, talk to me. And that concludes my part of the introduction. Thank you very much.
I'm going to hand over to Daniela Kunega from Rothoblaas, who is going to be our speaker for this afternoon, and he will share his knowledge and insight and everything else in between. So Daniela, I will hand over to you. Thank you so much.
So what about airtightness and waterproofing in timber structures? We will start talking about history, in which in so many centuries ago we were used to live in caves. So basically the idea was to protect ourselves from predators and weather, right? But in there, at that time, we were used to spend not that much time in one cave, let's say, but we were used to be more nomads, to move frequently. And then, sometime after, like in the case of this alpine region, you can see in here, alpine situation, humanity started to build their own structures to be more in one place only, to start, for example, building their families, starting hunting and growing vegetables and fruits, so that people had to think of how to protect their nest. And the technologies weren't so advanced like nowadays, but they started to select such materials that were perfect to last as much time as they could. So, for example, wood that could be for the structure and for thermal insulation as well, but by interpolating some stones, the nowadays cement, for example, between the ground and such timber structure, because as everybody might know, timber is very delicate, and moisture, water, and so on can damage it so fast. Moving on what we were going to talk now, I would like to start with some basics, air and wind tightness, then move into an hygrometric design with solutions like membranes and tapes, technical solution that we are already offering in the Rothoblaas catalog. And as last point, construction details, analysis of construction site problems, to have an overview on what could be possibly go wrong. Coming to our case, the example is like the following, in which a couple that just married has a woman, a wife that is dreaming of having a house with a nice view outside, nice panorama, big windows, and so on. Whereas the husband, man, is an engineer, civil engineer, and is thinking of having a very good performing house instead. And such are the 5 passive design basic principles, in which you will have to have thermal insulation, good thermal insulation, some passive house windows to not let so much solar radiation during summertime, for example, in your areas. An adequate ventilation strategy with some forced ventilation, and a good design in air tightness and wind tightness. This means also that thermal bridges have to be reduced, because as you will understand now in this presentation, with air flows, also heat with air we also have some heat losses. Try to think of this envelope, the ideal one, in which this house would be covered in Rothoblaas elements, Rothoblaas products. But the fact is that such membranes have a height of 1.5 meters or a maximum of 3 meters. And where you have to do the overlap of such membranes, you got to seal them, otherwise air will flow in there. So this won't be the perfect ideal envelope anymore, unless you do some tapings, sealings, and foaming as well. So the ideal case would be like an inflated balloon, in which we would like to keep our warm air in it in winter time, for example. And a good example would be the one of the clothes of an alpine skier, in which you can see in here the wind tightness is guaranteed by a Gore-Tex shield jacket that isn't letting wind come in. And below it, the ski alper is wearing a puffer jacket that offers an air tightness protection and is keeping the skier warm. So what does air tightness and wind tightness do? They prevent air leakage, and air leakage to result in living discomfort. They prevent heat loss in wintertime. They prevent cold air in summertime to be lost. And they also prevent penetration of wet air during summertime, right? So the phenomenon is to control temperature and moisture content. As you might know, we can't control the temperature, for example, outside, but we can control it inside only, inside our envelope. And the other way, we can control moisture content. This means we would like to control the quantity of moisture coming in our structure and the one coming out, right? So we got to control superficial temperature that can't be controlled, but yeah, just be monitored, and interstitial temperature. So as written in here, it is important to evaluate the resistance to the passage of steam of each material in the stratigraphy. This for vapor diffusion. About condensation instead, it happens in two ways. When the air is cooled to its dew point, and when the air becomes so saturated with water vapor that it cannot hold any more water. An example that I like to do is like when it's summertime and it's so warm when you came back from work and you just want to have a cold beer outside on your patio, and you grab it from the fridge. So the beer will be very cold. The surface of such glass bottle will be, let's say, clean, dry, but when you go outside in your patio, some condensation will start to be on the surface of the bottle. Otherwise, when you're showering and you want to dry your hairs, but there's plenty of condensation on the mirror, right? Okay, so this was meant to be a question to you, but as it is a webinar, I guess I will be answering. I will still ask you something. So let's think of these two situations. which would be the perfect position for the thermal insulation? Would it be this one, in which you have the thermal insulator in the structure, or would it be here, where you are having it in the outer part of it? So there's a wrong positioning, this one, in which you will end up having so much moisture condensation in there. Of course, it's not possible every time to have this positioning when you are doing a resto mode on buildings, for example, that have some historical protection, and you got to insulate it by the inner part. Otherwise, this one, the second one, would be the better solution, the best solution. And so which are the data, the values that we have to keep in mind to control these moisture condensation and moisture flow? Mu, that's a material property, and it is the water vapor diffusion factor, whereas the SD is the equivalent air thickness, which offers the same protection to vapor diffusion resistance, and it gets measured in meters. That, for example, is a situation in which superficial condensation wasn't being controlled correctly, but that's a local problem that you can solve pretty easily. Whereas if you take into consideration the whole assembly, the wall assembly, you got to consider of the resistance that every material has against water vapor diffusion. Just keep in mind that the higher the number, the higher the resistance will be. So with our timber frame structures, for example, we won't be able to get the same protection as reinforced concrete, for example, unless we do such walls that are, I don't know, 50 centimeters thick. And as you know, you probably know, it's not possible. That's why we are providing such technical solutions as membranes, water vapor diffusion membranes, are like less than a millimeter thick, and they are offering the same resistance. This instead would be the worst solution when you have some interstitial condensation. Actually, this was not the case of interstitial condensation only. This got some enhancing factors in which, for example, on the right side, there was a balcony with a wrong slope. The slope was in the direction of the wall instead of the other way, so water could accumulate in this joint between the balcony and the wall. In here, for example, as well, there was a timber beam, and the insulation wasn't correct. Like, yeah, afterwards, the whole facade had to be dismantled. And those would be the solutions, the technical solutions Rothoblaas is offering, for example, for wind tightness and air tightness as well. You will recognize them with the light blue color for wind tightness and air tightness with a red one. So how do people choose the right membrane, the fitting membrane for their solution? Those are the factors, the characteristics to be kept in mind: mass per unit area, breathability and water tightness, the climatic zone in which it has to be installed, the UV exposure of it, sorry, thermal resistance and fire reaction. Also some mechanical strength, because it happens sometimes that thermal insulation doesn't come with mattresses, but it's raw material, and it gets insulated by inside. So the membrane has to have some mechanical strength, net, as we call it. And here, as you can see, we are offering a range of products fitting for every situation in which you are. The transparent one that will go on the outer side, and moving till the barrier one, the one that protects the most, that offers a barrier against water and vapor diffusion, right? So such are the climatic zones in which you might be installing your membrane. And if we take the example of your zone, this would be warm, they find like a warm climate, and we would be offering transparent membrane on the outer part of the thermal insulator, and a climate control or a vapor one in the inner part. This for walls and this for roofs. Still not offering a barrier, so just breaks, not barriers. Let's have a look at which are the details that lead to the choice of such membranes. For example, when we have a very steep angle roof, we got to choose something that provides a tensile strength of 300 newtons over 50 millimeters, or resistant to nail tearing over 225 newtons. This means that all the load that is on the membrane will be affecting its resistance. Otherwise, in a roof that has a lower pitch angle, let's say, we got to have a mass per unit area higher than 200 grams per square meter, because in such low pitch angle roofs, it happens that the workers walk on there so frequently, so their shoes might be damaging with friction. They might be damaging the surface of our membrane. And we come to the distinction between monolithic and microporous membranes. So monolithic membranes are the most performing one, whereas the microporous one are the, let's call them the cheaper solution. It doesn't mean that they don't work, but they do work for other situations. That's the difference in the production phases, in which you can see the microporous one with a non-woven fabric over it, microporous film between them, and another non-woven fabric under it, whereas the monolithic one has a monolithic film over it and a non-woven fabric under it. The thing is that one works with physics and one works with history. So in here, the polymeric chains will let some vapor go through it. In here, instead, the porous material, the microporous material, will let the water vapor to go through it with capillarity. There it is. Water repellence for microporous membranes and hydrophobia a chemical property of the material for monolithic membranes. In here we see a test we did with microporous membrane and monolithic membrane. Many is the nail band we do provide for protection and water tightness under the buttons that are the structure for cladding in roofs. And yeah, as you can see, in a microporous membrane there was some water leaks without the Gemini nail band, whereas with a microporous membrane and a nail band there were no leaks coming through the thread of the screw. Whereas in here, without a Gemini, the monolithic membrane was already offering some protection, not enough, but still some more. And of course, with a nail band, more and more. In the center, there is an example in which we are offering such transparent membrane that is offering self-puncture-proof solution without having to use the nail band. As you can see, no water leaks. So let's have a look at this situation. I don't know if you also hear it, but water is dripping, and yeah, it's raining cat and dogs even inside the envelope. And we couldn't understand which was the cause of it. So there it is. I will speed up a little bit. It hadn't been taped on the overlap. This membrane hadn't been taped. This membrane wasn't offering the water tightness protection, so a nail band had to be used under the buttons. And this detail is very interesting. So the poor guy that drew this sign in it did a very good job by putting a risk mark in it so that the colleagues couldn't fall in this hole, but using such markers or sprayers, they did ruin the superficial protection that this microporous membrane had, so water leaked. Another example in this one, we can see that the membrane had been installed very good with tapes on the overlap, right membrane, right direction, even in this inward pinched roof, but there were some leaks. And the cause was the chainsaw. So as you might know, chainsaw need some oil to lube their chain, and while using it, some particles of oil were dripping from the chainsaw, and such oil drops, as you can imagine, ruin the superficial protection of the microporous membrane, and yeah, that's why it started to leak. Then we come into fire reaction of such membranes. They are categorized by this European classification, starting with the most performing one, class A1, to the class F. And as you know, membranes do not have the R labeling because they are not load bearing, but they will have the E and A and I labeling only, tightness and thermal insulation. If we start the video, you will notice that this one burns pretty easily, and it has been classified with E, and there are some droplets as well, some burning droplets that would let the thermal insulation to burn down. Whereas in this situation, there was some smokes, auto-originated smoke that would extinguish fire, and it also won't let droplets. This would be the most performing one that we are often classified with B as 1 for smoke production, and D0 means that no droplets are being realized. Coming to a very important subject nowadays, we got to talk of environment impact as well, and this is the list of the membranes which got this environmental product declaration based on the life cycle of this product. So not only focusing on their, let's say, installation life phase, but also on their manufacturing, distribution, and end of life phases as well. Another point for the right choice of the membrane is the environmental impact of them, or even the ease of installation. Such adhesive membranes, for example, they are easier to install because they can be installed in the factory, and then such CLT elements can be installed straight in their place in a building site. Such self-adhesive membranes are, for example, this one, that these are the definitive functional adhesive membranes. Such membranes get installed inside, and they do last till the end of the life cycle of such building. For example, this one on flat roofs, some others on the cement slab, and so on. Whereas there's some others that can be used for protection only, like for the transport from the factory to the building site only, like the defense adhesive removable, for example, or some others, like this defense adhesive. Defense adhesive is PD that doesn't have any liner, so it's really fast to be installed with this roller. It also comes with stripes for the overlaps. Otherwise, there's a transparent one. The transparent one is fitting really good in situation in which it gets installed in the building site where the moisture content in such CLT elements was already high, and this transparent membrane, when placed over it, also lets moisture to pass through it, and it will let the CLT element to dry. The defense adhesive removable is a nice way to protect such very high level, high quality elements to be protected through the transport, during the transport from the factory to the building site, and then be removed on site when installed, when the building site is coming to an end. And as Mark already introduced you, we do use some instruments like simulators. Ubacus is simulating a static situation, the one that you are setting up with humidity content and temperature content inside and outside our envelope. As you can see, you will be checking, for example, a typical roof stratigraphy, a typical roof assembly you are having in South Africa, I guess, for which you can check both the temperature and humidity quantity in this way. Otherwise, there's some other softwares that will let you simulate your situation in a dynamic way. You could test it like for 10 to 15 years, something like that, reproducing the weather, climate data of the previous 10 years, for example. And yeah, this would be a more safer way on getting to know if the stratigraphy is working across the whole year or not. Coming to the details, let's say we do also provide some tapes, nail points, sealants, and so on. As I told you on overlaps, we do have to cover and to seal everything, otherwise air will flow in, like in this case. And we're going to talk about tapes, which are the, let's say, characteristic we want to get from a tape. It has to have to offer some adhesion and cohesion as well. Some adhesion like honey, that's very adhesive and not very cohesive material, and some cohesion like concrete. Concrete is an example of a material which is poorly adhesive but very, very cohesive when dried. This would be the compromise to get. And such are the examples of tapes that we can use in our situation, in our envelope. From the outer part, sealing this velux, for example, this opening, inside with a double liner that would be helping you install it in such angles and edges. Otherwise, there's the speedy band, the one without the film, without the liner, so you could use less plastic, less time as well. And there's a UV protected tape as well that could be installed, for example, under some ventilated facades, and also under some solar panels in a roof. As I told you, the nail band would also be one way to go for your waterproof. A butyl nail point or a double-sided nail point to prevent any water leakage coming through the screw. Sealants as well. Sealants would be helping you in such situation in which the surface might be more rough, the surface in which you want to install your membrane, or when, for example, you are using such non-self-adhesive membranes, you might be thinking of using some sealants, outside glue or membrane glue. Both would do the job. One is an acrylic one, and the other one a butyl-based one. There's some bands as well that are still offering it without having to use such guns, silicone guns, or a double band as well for the overlaps. Foams and expanding tapes as well to close every air passage, because as I told you, it is in details that air will flow in and flow out and disturb and ruin the let's call it the perceivance of such users in our buildings. There's some closed cells and open cells foams. We do suggest more the closed one, so that if being cutted down, fitting the structure, let's say, it won't ruin the wind tightness and air tightness. Some other examples for such details for installation passages with such adhesive sealants bituminous based one, someone for roof as well, and those interesting one are just for installation of electric pipe connections without having such pipes going one element through both wall and slab elements, and yeah, it will reduce the time, installation times, and risk as well. Tapes, foams, and sealants do also offer such fire protection. They are fire rated as well. And those were the situation in which we tested them. For example, the junction between CLT panels, like in this one, and this foam, for example, is telling you that it would protect the other side for about 240 minutes, but in this situation only, because it gets guaranteed in the only situation in which you tested it. This goes for the bands as well, foams as well. Otherwise, yeah, it might be that fire comes in, goes through the structure, and when it reaches to such metallic elements, you would better know me that metal is transmitting temperature more than timber, that is like an insulating material instead. And yeah, so I didn't let you so much time for question if you had some doubts as well, but as it's in the as there is some time at the end of the presentation, I remain available for any further questions. And yeah, I thank you for your attention. This was the end of my presentation.
Thank you, Daniela. Yes, as you say, more wood, less CO2. And we need to grow the solution for improved built environments. So thank you for your contribution. Bram de Villiers, in fact, Daniela, has a question. Perhaps you could explain a bit more how the inside membrane helps with moisture control to the outside. So what types would you use?
So sorry if I wasn't clear enough, but you are it happens sometime that even in Italy, for example, I do the example of the Italian market, as I am following mostly Italian market. So such builders think that the way of doing it is to provide some either air tightness or wind tightness, and that's basically wrong because you are doing it halfway. So you got to think of protecting with air tightness from inside with a barrier membrane, the one that is offering more resistance to the water transport. So like with some higher SD values, like around 20 or something like that. And yeah, the commercial names of ours are barrier and vapor, for example, the one that are being placed inside in the warmer part of the wall assembly, for example. Whereas for the cold part of it, the side in which you are offering wind tightness, there a less protectant, a less resistant membrane, so like a more transparent one with an SD value of around 0.2, for example, would do the job.
So I would like to hand over to Scott Sargent from Rhinowood. He is the representative of our other sponsor for today. So if I just want to make sure that he is there. Yes, he is. So Scott, over to you. Thank you very much.
Yeah, hi everyone. Thanks, Samantha, and thanks for the opportunity to present our industry and also obviously our business. I'm just going to get my presentation up. Okay, so by way of introduction, my name is Scott Sargent. I'm founder and MD of Rhinowood. We are a wood modification business, which I'll touch on in a bit now, based in Johannesburg, but distribute all over the country and then also sub-Saharan Africa, parts of Europe and the States. Our primary mission is to provide a truly sustainable real wood alternative to your natural forest hardwoods. So generally speaking, timbers come in all forms, shapes, sizes, and they all have different characteristics. So there's no silver bullet for any one application by one timber. Traditionally speaking, and very much generally speaking, hardwoods come from natural growth, natural forests. They're slower growing, a lot more durable. They have natural strength, and a lot of them have natural resistance to wood destroying insects. So the hardwoods really were the initial sort of timbers that were used in construction for any kind of application. Then on the other end, we've got softwood, mainly plantation grown, but obviously there definitely are softwood timbers that grow naturally and hardwood timbers that are farmed, but this is traditionally why they are grown and plantation grown is because of their fast growth. But because of that fast growth, there are some downsides to that. The faster the growth, the less durable it'll be, the less load-bearing capacities or limited in strength. And a lot of these softwoods are not resistant to any wood-destroying insects or fungi. And that then introduces a relatively new, it's been around for a long time, but a relatively new sector of the timber market, and that's modified wood. So just to read this out to you, wood modification involves the action of a chemical, biological, or physical agent upon the material, resulting in a desired property enhancement during the service life of the modified wood. The modified wood should itself be non-toxic under service conditions, and furthermore, there should be no release of any toxic substances during service or at the end of life following disposal or recycle of the modified wood. If the modification is intended for improved resistance to biological attack, then the mode of action should be non-biocidal. So that just gives you a basic, the basic premise would be that you're taking a fast-growing, sustainably grown softwood, and through different technologies, you are creating something that is comparable to those hardwoods, traditionally for outdoor applications. So just to touch on a few wood modification technologies, widely done throughout the world is thermal modification. And in essence, that is subjecting the timber to high temperatures in very controlled environments. Basically, you are dispelling all the moisture, you're polymerizing the sugars and the resins in that timber, and then the most important thing, you're attacking the hydroxyl groups, which are traditionally the groups in the timber that like to absorb and hold moisture. It also obviously gives the timber a different aesthetic, and depending on your time and your temperature, you're going to get some variations in terms of color, but it gives basically you aim for a nice walnut brown color. A second way of wood modification is chemical modification. It's externally applied chemical reactant, which once again is aimed to attack the hydroxyl groups. There's, I mean, for example, commercially available chemically modification would be Accoya, probably the market leader in the wood modification business throughout the world. And then lastly, you have an impregnation process, and that's basically a full cell that can be done with a resin, a wax, any kind of polymer, and that basically fills the cells of the timber, solidifies in there, and then creates a great increase in your strength, the inability for timber for water to be absorbed and dispelled. So yeah, that's the basic three. There are obviously others and some burgeoning technologies that are coming onto the market, but those three would be your most commercially viable or available, should I say, at this point. So on that topic, just to explain a little bit about our company, we use a two-stage process, although it is a continuous process. We use a oil heat transfer way of thermally modifying the wood. That's basically railing the wood into autoclaves, filling it with our non-toxic compound, heating it to 220 degrees Celsius over an extended period of time. And as I mentioned, that polymerizes sugars, resins, and attacks the hydroxyl groups. We then take it one step further, and we do a pressure impregnation with this non-toxic compound. It's a high melt point hard wax that we use, and we blended that over the years. It was born out of a 30-year-old family chemical business, and this is a technology that we've developed over quite a period of time. And as mentioned again, this compound is impregnated to the core of the timber. It fills all the cells. So traditionally, your pine or any coniferous species is quite receptive to an impregnation process. Certain timber species, sort of the Selignas and some other hardwoods, are less prone to absorbing. So the whole idea is to take that soft-grown, porous wood and then be able to make it into that hard, durable timber that can be used for your external applications. So sustainably sourced, heat-treated, pressure impregnated, and that's how you get the end result, which is Rhinowood. There's a lot of talk, obviously, of sustainability, greenwashing, you name it. So we're very, very cautious and very aware of our claims. Just to give you an idea, we are FSC accredited. We only source from responsibly sourced growth and, sorry, I'm losing my words here, responsibly grown timber throughout the country. All of our stuff does come from within South Africa. We don't believe in importing timbers to do this process. We do have a great supply of timber. We also do like to get a clear grade or a semi-clear grade, meaning less knots or tight knot spec. So in our process of pressure and heat, if it is a loose knot, we do tend to get popping. So just in terms of waste and aesthetic, we like to get a very, very good quality of pine through our process. And another, maybe just to touch on the sustainability again, in 2014, we were awarded a WWF Climate Solver Award, and that was due to our work against deforestation. So as I mentioned to you, those hardwoods that are normally used for your outdoor applications come from century-old forests, and we would like to present an alternative to those, in a local alternative, so you don't need to rip out those forests and transport timber all over the world. You can certainly use a sustainable but hard-wearing product locally, and we do export quite a lot to sub-Saharan, so we do try and keep it as close to home. Just some of the benefits that do occur with our modification process. We put a 60% increase on the load-bearing capacity from your normal pine. Your surface hardness is increased drastically. So your Janka hardness tests would be equivalent and sometimes supersede. So your Balaus and Garappas, we have a harder surface hardness, which obviously for decking applications in terms of dents, scratches, and surface damage is obviously quite important. Reduced fungal decay and rot, and this is probably the most important thing. We've got a class 1 durability rating in use class 3, and your use class 3 is basically anything above ground but within the elements. So once again, cladding, decking, any outdoor application. So yeah, that with that class 1, we are able to market a 25-year service life against fungal decay and rot. We currently are 15 years into our in situ testing. So that's what we give at the moment, and as we increase, we do increase that warranty. But by all accounts, we did accelerated weather testing and durability testing in Germany, and we're given a Class 1. And as I said, you can legally allow people to believe, to assume that that's a 25-year plus. Durability, once again, I've touched on that. And then dimensional stability through that process of the thermal modification and then the pressure impregnation, you get a dimensionally stable product that it reduces ability for it to absorb and dispel moisture, which is the common cause of swelling, warping, and any kind of timber movement. Obviously, we're very, very conscious of what we put into that timber and how we actually manufacture it. So the compound we use has zero toxicity. It doesn't have any heavy metals, no plastics, and no biocides. And yes, it can be disposed of after its service life without causing any issue to the environment. And very important, and almost, I wouldn't say dumb luck, but we weren't planning on this, but a reduced wood borer and termite damage. We're into our 13th year of SABS termite testings in situ in the Springbok Flats just north of Pretoria. And I'm happy to share all of those results and any other results that anybody requires to obviously back up our claims. But I visit there once a year in July, and this last July was quite inspirational to see what condition the timber was in terms of this borer or termite attack. Obviously, we replaced the control boards every single year, and they were absolutely decimated, and our timber was still looking very, very strong. Slight little etching on some of the boards, but we've done some further research, and due to the molecular structure of the compound, although it is still a real wood, termites and wood borer don't really recognize it and don't want to absorb it into their systems. I did touch on disposal. You can dispose it of like any untreated timber. Environmentally friendly, I've spoken of. Maybe I can just add to that, our manufacturing, we don't use any water. We process all our own heat from our waste. So we're very conscious of our footprint in terms of our manufacturing. And then a very, very good marketing, but a good point for anybody is it's low maintenance. So because we treat it to the core, if you cross cut or drill into, you're never exposing any timber that is not treated. It's not a surface treatment. It really is to the core of the timber and fills every single cell. And apart from giving it a clean, depending on your atmospheric conditions or where you're based, you don't need to sand and seal in order to maintain the integrity and the integrity of the timber. Just to touch on a few applications that we have, I'd say 60% of our business at this stage would be decking. We offer two different thicknesses, a 20 millimeter, which is a very standard board, and a 65, 100, and 136, and that's an S4S E4E, and you can get in a brushed and natural. The same along the lines with a 27, although that's an S4S S4S. Okay, I've said E4. Sorry, it should be E2E there. So it's arrest on the top two sides and then a flat bottom. That can also be grooved. The 27 mil can be grooved for the secret fixing clip systems, and you've also got the benefit of your spanning distances. So you can go up to 650 center to center spanning on that 27 board, and on the 20 board you can go to 450 maximum. So yeah, just due to the fact that we do increase the surface, the load bearing capacity, you do have the luxury of longer spanning. Another very popular product market is for cladding, and here maybe I should also mention now that one of the things about Rhinowood is it's a very dense product. It comes in at 950 kgs a cubic meter. So in some applications where your weight is an issue, we created a 13 mil board, and that comes in a 48 to 65, 100, and a 136. And we've got a whole bunch of different moldings that we do that are standard. We can look at custom moldings, but as a manufacturing plant over the years, we prefer to stick to our standards, that being just that aerosol round S4S, E4E, a nice bill nose, and then a very popular one is the shiplap, and that can be done in a 13, a 20, a 30, or even a 40 mil. The 30s and the 40s, excuse me, are mainly used for battens in the cladding application. They're quite popular at the moment. That can be a square PAR, which is planed all round, gives a nice square cylindrical look, or not cylindrical, a square look. And yeah, those applications are increasingly popular. We do pergolas and solid beams, and these can also, the larger items can be used for handrails, balustrades, you name it. So yeah, it's, once again, there's a 30 millimeter thick, a 40, and that 30 can go up to 200 millimeter wide. We are traditionally sort of, in terms of our sizes, we're restricted by what we get from the mills. So we've had to adapt from our supplier what we believe is the best for market, and that's why we've come up with these dimensions. You'll see a whole bunch of different timbers, even playing in the same space, will possibly have different cuts, and that would just be, once again, what is the best recovery you get from your raw materials. This just gives an overall view of all of our characteristics, as I've mentioned over the course of the presentation. Once again, these are freely available, so if anybody wants any of the test results or any further information on these specifications, please feel free to question or ask, or send us an email. And I think I've covered most of that. Once again, getting back to the maintenance, it's one of the big selling points of Rhinowood, is that you do not need to sand and seal and oil over years to retain that integrity. So we suggest that you can give it a wash and you can re-oil it. And this is an example of a weir that are newly installed, so you can see that color difference. We really do advocate that a customer lets it weather to that silvery gray. We do feel that that is in its best application and weathering, and it does tend to go to a very, very nice silvery gray color that a lot of people do like. Obviously, you can't please the market all the time, so if people do want to, they can wash and then oil. We don't use any varnishes or any kind of coatings other than penetrating oils. And they do penetrate, and once again, there are a number of different commercially available oils that we could suggest that you use, both locally and international brands. Your color change will definitely depend on your exposure. In South African sun, the material takes 6 to 9 months to fully weather to a gray, so it is a fairly quick process in terms of timber. And this color will maintain in terms for its lifespan, provided that you give it an occasional wash. Just some examples of some projects that we've been involved in, just some EU projects. These are Sicily and Italy, and Switzerland. Top left is a Swiss job that we did. And funny enough, that the trees at the bottom right here, that's Shakira's house in Cyprus. So just dropping a bit of a name there. Some sort of key projects we've done in South Africa. De Hoop Nature Reserve, Lakavata, a great beach lodge, obviously close to the sea. They used a 13627 brushed finish there. Excuse me. And here are just some further pictures of it. Just to maybe on the bottom right there, screen right, you'll see that the timber inside and outside is the same. So we do a tongue and groove flooring, and for lodges, that's quite a popular thing to maintain that aesthetic from your internal to your external. Pazula Nature Hotel in Knysna. This is possibly close to one of our first jobs. About 2013 this was laid, and I do visit that area and can say that it's still looking fantastic. So just to give you a commercial property, this is Circa Gallery in Johannesburg, part of Everard Reed, and we did the walkways up the circular to the mezzanine level and then to the roof level, and then we've got a deck on the roof. That was also a 13627 top-down screw fixing. Another commercial, Hotel Sky. This was a fantastic project for us in terms of quantity, but also just the exposure. And it's on basically every floor of the stairs, around all the pool decks, and obviously a great view of Table Mountain. The Leonardo in Johannesburg, highest building in Southern Africa. Pergolas, as you can see, and then decking. So that just shows a few applications, and you can see that it has weathered there to that grey. This was literally our first project. It's Matlasana Mall in Klerksdorp. So that was just end of 2012 that we did this installation. Private residence, so you can see some 30 by 30 slats for screens there, decking, some wall cladding. So that's just showing you just the different sort of products that we can do and what they look like in terms of being in situ. And then a big part of it.
I'm going to have to ask you to wrap up
That's
quickly
fine.
because we do have quite a few questions for you,
Okay.
and we still need to have some closing remarks from Tafadzwa. If I may, let me just read the questions, and then yeah, hopefully you can answer them fairly quickly. But firstly, my side, thank you for your support of the local sector. That's always good to hear. And then I think you did eventually answer this, but does Rhinowood offer structural sizes of timber for pergolas and decks? I think you covered that in your presentation.
Yes, we do.
Yes.
So we do a lot of pergolas, and we've got different designs for different, you know, from standalone to steel structures to you name it. We can help people design, and we've got different structures for that. Yeah.
Great. And then we'll, I think also would bear the extreme summer dry heat?
Yeah, so I mean, we've got projects from Namibia to the Seychelles and basically everything in between. So yeah, we're pretty confident that, you know, we've got a lot up in Joburg, and it's dry winters, and then the dry summers in Botswana's sort of areas and Namibia's. So yeah, we can reference projects from all over in different environmental conditions. Yeah.
And then would you recommend any additional coating? I think you may have even answered this. Any additional coating after construction to reduce the degradation of the surface in the wood for cladding, such as Pro Nature?
So Pro Nature, great brand. We do work with them, but it depends. It's mainly an aesthetic. So as I mentioned, in terms of actually oiling it to help the integrity is not necessary. But we always talk about coatings to be, it's somebody's personal aesthetic. So if they don't want that graying color, and I mentioned 6 to 9 months of graying on a vertical, I mean a horizontal, so your cladding applications, that could be up to about 18 months. And then oils, yeah, we've used extensive oils, Jaxolium, Pro Nature, of course, and then Osmo and a few other brands from international companies. And yeah, you can, but it's not necessary.
Thank you. And then from Van Slubbert, you mentioned that your treated timber structural strength increases by 60%. This could mean that it could technically increase S5 member to an S8. So is the timber graded by ASBS or SATAS to a higher grade? And if so, we could include these standards in our SANS 182 225. So yeah, just
so we would love that.
Question.
Unfortunately, with modified timbers, it seems to fall still into a little bit of a space where nobody knows where to put it in terms of SABS and all the rest of it. So we are pushing on that. We've done modulus of rupture, modulus of elasticity. We've done load bearing, all overseas. And we would like to get it registered for structural. We don't at this stage do much structural in terms of bar your pergolas and stuff, but that's not truly structural. One of the, I'd say maybe the shortcomings for structural, and if you're looking at trussing, is the weight of the timber. So we have, sort of haven't really found a market in trusses and the like. So, but we would like to get it, tested by SATAS and get some kind of rating on it. They just, as I said, they mainly work with pine or CCA treated pine, and they're just battling to understand where to position us.
Okay, well, I'm sure as a sector we can help support you there. Thank you. Oh, I see Skulk. You've got a question? Prof. Skulk's Krobler. I see he's. Do you want to unmute there?
Hi, Scott.
Hi, Skulk.
You should send it to us. We'll break it for you.
Perfect.
And we'll give you the stats.
Okay, perfect. Well, then we'll chat.
There we go. Like I said, not what you know, it's who you know. So thanks, Scott. That was, if I can reference Shakira, Waka Waka. So thank you very much. Just to conclude, thanks, Scott. Scott, thank you, Mark. Thank you, Daniela, for your. Thank you for supporting our sector. The aim of these webinars is to promote the use of local South African grown timber, and yeah, we pride ourselves on renewability and sustainability of our timber plantations. No, when we cut down or harvest the trees in our plantations, it is not deforestation. So I also want to add that if you do have any CPD related queries, please email Ferdinand Hassan. His email is in the chat. So please, you're welcome to email. I know often we have some issues getting certificates, and especially with this particular webinar, I believe we had both of them you had to attend both of them to qualify for CPD, but we can address those issues after the webinar. Thanks, Ferdinand. I see his email is in the chat. I want to now hand over to Tafadzwa Nyazunda. She is the Director of Industry Development. Let me just make sure I get your title here. Director of Industry Development for our forestry-based industries at the DTIC. So Tafadzwa, may I ask you to wrap up, please?
Thank you. Thank you very much. I think firstly, I've learned, I like the presentation from our main presenter on the air tightness. Yeah, so I did learn quite a lot there. And let me just, before I go into the vote of thanks, say a few things. We do have a LinkedIn group. So if you are not in the LinkedIn group, that is always posting activities and news to do with timber construction in South Africa, we urge you to join. I would ask Ferdinand to post the links to the chat. Similarly, there is also a Facebook group that you could also join. So like Roy said in the beginning, that we are seeing the strides, the Talking Timber webinars are growing. When we started, it was like 20 people. I've just looked at when 2023, this similar webinar, when we did it, we had 158 people on the LinkedIn group. Now we are standing at 1,015 people. So we expect more to join. The Facebook group had 118 people. We're now on 493. So if you are not there, please join. We will send Scott's details to you, Joy. That's fine. There is also a Wood app. A Wood app where we have about 12 courses on timber construction. So if you are already a professional and you need to learn more on timber construction, the Wood app is your place. There is all the material that you can learn on. And in 2026, we've just had our timber construction conference in September. If you missed, you can also just go to the website and see the papers have been posted and the presentation. And do not miss the 2026 conference. It will happen on the 14th and the 15th of September 2026. So on the 14th, we have the timber research colloquium, and then on the 26th, we do have the conference. So I think that is all that I needed to speak about. And I know that there is also a conference that is happening next week on timber. I think Ferdinand can also put a link. If you had not yet subscribed in Cape Town, you can also attend to that one. My sincere gratitude goes to our presenters, Mark O'Connor from Rothoblaas, who did just talked about their company, and also Danielle, who also then gave us the main presentation. And Mark did acknowledge they've been there since we started. He did a presentation as well on this webinar that I've been referring to in 2023. And here you are again. So thank you to Rothoblaas. I would also like to thank the attendees. As Roy said, we are growing and growing. So next time you look for the next webinar, it should be maybe around February, March 2026. We usually have 4 webinars in a year. So we hope that you'll be able to join again next year. We also would like to thank our sponsors and our partners. So this webinar was sponsored by Rothoblaas as well as Rhinowood. And thank you also for the presenting. Sawmilling South Africa is the partner to this work. SOPA, University of Stellenbosch, University of Pretoria, University of Nelson Mandela, and also the Pretoria Institute of Architects. Earthworld, yes, represented by Bram de Villiers, has been here from the beginning. Thank you so much. The webinar organizer, as well as our program director, Samantha, as well as Ferdinand, thank you for the great work that you continue to do. And I think to the rest of the participants and the sawmilling industry, as well as the engineered timber manufacturers, to the architects and the engineers, thank you for making this work. And we are seeing timber, beginning to see quite a bit of timber in our built environment. We want to see more of that. So thank you for dedicating 1.5 hours on this webinar Thursday, and enjoy the rest of your day. Thank you.